All right, Miss Anna, we're looking at a problem set you had worked on. This is the first one deals with anaerobic oxidation of methane. Let's jump to your first question here. Suppose that in study 1 at the same location, samples of ocean floor sediment from 20 to 20.5 centimeters below the ocean floor surface have been collected and combined. The pore water extracted from those combined samples would most likely have an average sulfate concentration, average methane concentration, respectively, to which of the following? All right, so let's go back to study 1. Study 1 deals with determining the amount of those two chemicals. And so we have a table here that shows how those concentrations of chemicals change as I increase in my depth below the ocean floor. So I can see that my sulfate, for example, is the greatest at the top. We're getting roughly 25 millimoles per liter, and then it decreases rapidly with depth. And so by the time I get to 3 centimeters below the surface, I'm at 0, and it continues to be 0. Whereas methane, the amount of methane actually increases with depth until it gets to, roughly 65, maybe just a smidgen more. Okay, so let's go back to our question here. We're basically going to look at that sample a little bit deeper. Okay, the figure here only goes to 20 centimeters, but they're asking you to predict what would you expect if you went another ½ centimeter. Okay, so look at your trend again. Your sulfate is 0 at 20, and it's been 0 all the way from 3 all the way to 20. So why would you expect it to be any greater than that? So it's going to be expected to be 0. And your methane, it's declining with depth. It's increasing with depth until it gets to about 65, and then that trend appears to continue. If I went another ½ centimeter, I'm probably still going to be at 65. So based on that, what are our choices here? Like we said, we're not going to expect our sulfate to increase all of a sudden at 20. That wouldn't make any sense. So we'll go ahead and take these two out, H and J. And then, so that gives a sulfate prediction of 0, and then like I said, we can expect our methane to be about 65. So that's going to give us G as our best answer there. Alright, then going to 33. Consider the average percent by mass of argonite at a depth of 10 centimeters shown in figure 3. On average, the mass in grams of argonite present in a 50-gram sample of sediment taken from that depth will be closest to which of the following? Alright, so here we go with figure 3. They are asking about 10 centimeters deep, and so I go to my 10 centimeters deep to my y-axis. I'm going to read across until I hit my argonite line, which is right here, this dotted line. And if I come down, we're talking about a 10% average by mass in the sediment. So that's going to be a 10%. So if I go to here, they're asking about a 50-gram sample, so 50 grams times 10% is going to give me a 5-gram answer there. So B is my best choice there. Alright, then our next passage here deals with bacteria breaking down sugars by fermentation. Let's take a look at your first question. Suppose that in experiment 2, both species B and C had been added to a large test tube containing sucrose broth and to a large test tube containing lactose broth. Which of the following would most likely depict the results? So if I put B to C together, what would I expect to happen? So experiment 2, I didn't actually test B and C. They're asking me to make a prediction. So what you're going to have to actually do is go back, in my opinion, to experiment 1. Species B gives me negative results for acid and carbon dioxide when given sucrose, but it does give me positive acid test as well as a positive gas test for lactose. Species C gives me positive acid, positive gas for sucrose, but negative lactose for acid and negative gas test when given lactose. Okay, so B by itself gives me negative, negative, positive, positive. C by itself gives me positive, positive, negative, negative. So if I put them together, I should be able to get positive for every single test, no matter what the sugar. Okay, so if I come back over here to 29. If I had put these two species together, like I said, I should get positive acid, okay, because species C did break down the sucrose and produce the acid. I should get positive gas there as well, and then I should get positive acid test when given lactose because species B could produce that acid, and then species B could also give me a positive gas test. So I should get positive results on all four. And then suppose the scientist isolates a bacterial species that is one of the four using experiment 1. She adds the species to sucrose broth and observes that neither acid nor CO2 is produced. When she gives that species lactose, however, we get both an acid and gas test that are positive. Based on the results of experiment 1, which species are we dealing with here? Okay, so what was it again? I get negative for acid and CO2, but I get positive for acid and CO2 if I give it lactose. So sucrose negative negative and lactose positive positive. So sucrose negative negative, so that's going to rule out C and D. So it's between A and B right now, but then lactose is positive positive. So the only one that would do that would be species B, negative negative positive positive. Because A would be negative 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 negative, and I knew I got positive for acid and CO2 if I gave it lactose, so it's got to be species B, which is going to be letter G as your best answer. Alright, then question 33. Is the hypothesis that species A and C acted synergistically supported by the results of experiment 2? Alright, let's take a look at experiment 2, A and C. If I put A and C together, I get positive acid, positive gas when given sucrose, and I get negative acid, negative gas when I give it lactose. Okay, that's fine, but I need to be able to compare that. What if I have A by itself? A by itself gives me negative across the board. I get no positive result for A by itself. C by itself gives me positive, positive, negative, negative. Well, A and C together is actually giving me the same thing that C would give by itself. So it's not as if A and C are sort of helping each other metabolize anything. It's not giving me any unique result. Okay, and the synergism that is mentioned up here, it's allowing two bacterial species to act together to ferment a sugar that neither one can use alone. Okay, so lactose is not being metabolized there. So let's go to our choices here. So right away I can take out the yeses. Okay, again because they're not showing any results that are indicating synergism. A and C together are giving me the same result as if I had C by itself. C by itself was negative for lactose, and A and C together did not give me a positive for metabolizing lactose, acid or carbon dioxide. So that's going to give, looks like D is my best answer there because neither acid nor CO2 was produced from the lactose. Okay, and recall that lactose was not metabolized by C and it was not metabolized by A. And if these were working synergistically, I should expect a lactose medium to give a positive result for the acid or the CO2, one or the other, or even both. But I didn't get that, so I don't have any results that would give me any indication of synergism. Okay, and then we move on to the passage here about the blocks being pulled across the horizontal surface. The first question here, 26. Based on figure 1, the results of experiment 1 are best modeled by which of the following equations? Alright, so figure 1, we have a linear line, right? Y equals mx plus b. Okay, so I know b, my y-intercept is 0, so basically y equals mx. Y is my pulling force newtons. So N equals, what's my slope going to be? Well, I have, for every 1 on the x, I gain 5. So I gain 1, I gain 5. So my slope is 5, and then my x value is kilograms. So which of these equations is going to give me, sort of show that graph, or this graph shows which equation? Block speed equals, now I know that this is not my slope, so I'm just going to take those two out. And then, frankly, time is not part of the figure 1, so I'm just going to take those out. So just based on that, it gives me J, which is actually right. Newtons equals, here's my slope, and then here's my x value. Y equals mx. Okay. Let's go to 27. At each of the times plotted in figure 2, except for at time 0, as block mass increases, block speed does what? Okay, so let's take a look. Here's figure 2. Alright, so we're talking about at each of the times. So let's just look at, say, 1 second. My 2 kilogram block has a speed of 10 meters per second. My 2.5 is roughly 7 meters per second. And then the 3 kilogram block is about 5 meters per second. And that same pattern holds true no matter which time interval I'm at. So as my mass is getting greater, my speed is actually decreasing. Okay. And then 28. Based on figure 1, an applied force of 300 newtons would most likely have been required to maintain a constant speed of a block having a mass of what? Alright, so we go back to figure 1. Okay, so remember I had a slope of 5, right? I had a slope of 5. So if I had a 30 newtons of pulling force, and I know that my ratio is 5 newtons per kilogram, basically if we solve for x there, that should give me the mass that I need to be concerned with. Okay, and I can see clearly that's going to be 6. X equals 6 kilograms. And if I actually look at my graph, I can kind of see that as well. 4 kilograms is giving me a Newton force of about 20. 3 is 15. So for every kilogram, I'm adding 5. So 3 is 15, 4 is 20, 5 should be 25, and then 6 should be 30. So I'm kind of looking at it two different ways. I can look at it graphically, or if I just look at it mathematically here, I should get 6 kilograms as my answer. Okay, good luck on your test tomorrow. I believe you're taking it tomorrow, so do your best and good luck.